Hi everyone, in this video we're going to look at how to do stoichiometry. Before we continue, make sure you are familiar with all the different formulas, including how to convert between moles and masses, moles and volume, moles and concentration. Alright, this video will cover the examples in your notes and it is organized in 3 sections. The first section we will look at how to do calculations based on chemical equations. In the second section, it is the same thing, but we are going to apply that to the context of a titration experiment, and this is called volumetric analysis. And finally, in the last section, we will look at how we can do a shortcut method when we are doing calculation using gases. So generally, when we talk about stoichiometry, right, there are 4 steps that you need to do when you approach a question. The first is always to have a balanced chemical equation. And the keyword here is balanced, otherwise your mole ratio later will be wrong. Next will be always to find out the number of moles of something. This is based on whatever that's given you in the question. Then we look at the mole ratio, and then finally we convert it back to whatever quantity that we want to find. Okay, so we look at one example here where we are asked to calculate the mass of water formed when 1 gram of hydrogen gas is burnt in excess oxygen. So how you do, right, is that you can look at the equation like this. I start with 1 gram. I want to know what is the mass of water formed. Remember, the first step is the equation balanced? Yes. The next step will be to compare moles. In the equation, right, we have a 2:2, but this 2:2 is in terms of the number of particles or number of moles, not in terms of mass. So your very first step will be to convert this into number of moles. So number of moles is the mass over the molar mass. Okay, and you know molar mass has the same value as the mR. In other words, for the number of moles of hydrogen in 1 gram, we just take 1 gram divided by 2 because hydrogen is H2. That will give us 0.5. So now I will change this 0.5 mole, right? Once you have the number of moles, you can cross the bridge. 2:2 will mean I will get 0.5 is to 0.5. So how much water is there in 0.5 mole? We can take the number of mole times the molar mass, same value as mR, you get 9 gram. Okay, so calculations wise, you can always give to 3 significant figures and write it as 9.00. So for those of you who prefer a visual representation, this is what we start with. Okay, always convert to mole first, cross the bridge, then convert back to whatever quantity they want you to find. So we look at another example. I want to find the mass of water produced when 6 grams of methane is completely burnt in oxygen. So first step, again, let's have a chemical equation, make sure it's balanced. Next, ask yourself what is given in the question. In the question, tell me I have 6 grams of methane. I need to find the mass of water. So remember, if I'm given mass or whatever quantity, I must convert it to moles first. Okay, so first find out how many moles is this. And when you cross the bridge, how many moles is formed. So if we look at step 2, we have 0.375 mole here. Mass over mR. This is a 1:2 ratio. So I need to multiply the number of moles times 2. Here I get 0.75 mole. So 0.75 mole I need to convert. How many grams is this? Okay, so we need to times the mR of water, H2O. So 2 times 1 plus 16. That's why you have a times 18 here. So the final answer is 13.5 grams. Okay, so I hope that you can see whenever we do a calculation, start with the chemical equation, look at what is given, find moles, mole ratio, then convert again. Now I'll pause here. You try the checkpoint questions first, then I'll go through the answers with you. 36 grams of steam can be obtained from 16 grams of oxygen. Over here, we cannot just compare masses like this, right? So what you need to do is to go and calculate how many moles is this? 36 gram. Okay, so you do your mass over your MR. So this is 2 mole lah. Okay, 16 gram of oxygen, in other words, would be 16 over 32. Remember, oxygen is O2. So you have 0.5 mole. Is this correct? So the equation says that 2 mole of steam is formed from 1 mole of oxygen. Okay, not 0.5. So A is wrong. Okay, look at option B. 2 gram of hydrogen combined with 1 gram of oxygen. Remember, this 2:1 is not a mass ratio. So B is wrong. It's a mole ratio. Option C, 2 mole of steam can be obtained from 1 mole of oxygen. Yes, that was what we mentioned just now. That's correct. Option D, 2 atoms of hydrogen combined with 2 atoms of oxygen. That's not correct. Should be 2 molecules of hydrogen combined with 1 molecule of oxygen. Okay, so answer here is C. Alright, question number 2. Always start by identifying what is the information given in the question. 56 gram of nitrogen. Balance equation already given. My first step, find number of moles of nitrogen gas. Mass over 2 nitrogen. What is the number of moles of ammonia formed? This is a 1:2. So this will be 4 mole, right? How do you present it? You can say mole ratio of N2 to NH3 equals to 1:2. So that means if I have 2 moles of nitrogen, right, I will have how many moles of ammonia? 4. Okay. Next, mass of ammonia will be equal to 4 times the MR, NH3. So you should have 68 grams. Right, try the next question. Right, this question equation is given. Let's do A part 1. This should be the relative formula mass because it's an ionic compound. Calculate the MR. MR would be calcium, 2 of nitrogen, 6 oxygen. That will give us 164. Part 2, calculate number of moles of calcium nitrate. Will be the mass over the MR, 0.02 mole. Mass of calcium oxide formed. So we are comparing here to here. Whenever you cross the bridge, go over to from the left to right, you compare the mole ratio. So 0.02 is to 0.02 because it's a 1:1 ratio. Okay, so the number of moles of calcium oxide is also 0.02 mole. Therefore, the mass of calcium oxide would be 1.12 gram. Okay, part B. If 1 mole of calcium nitrate were heated, how many moles of gases are given off? Going back to the equation, where are our gases? These are our gases. How many moles of gases do we have in total? 4 plus 1, right? 5 mole. So in other words, 2 mole of calcium nitrate give 5 moles of gases. Question asks, 1 mole of calcium nitrate gives how many mole? So very easy. The answer is divide by 2 lah, 2.5. Okay, so how do you present? So from the equation, 2 mole of calcium nitrate gives 5 mole of gases. Therefore, 1 mole gives 2.5 mole of gases. Alright, so that is stoichiometry. You will find that the approach is rather similar. We have the balance equation, find moles, compare the ratio, then you find the other thing. Okay, so that is it. I can even ask a next part, right? So using your answer here, right, 2.5 mole of gases, what is the volume of the gases? So you know that number of moles is volume of gas over 24 dm cube. So which means 2.5 mole, right? You get 2.5 times 24, that is 60 dm cube. So with that equation, you can actually work out a lot of things based on the number of moles. Alright, volumetric analysis, as the term means, involves volumes, and these volumes refer to volumes of solution. And when we talk about volumetric analysis, most of the time is to do with titration lah. Okay, so in titration experiment, you have a burette, and then you have your substance in the conical flask here. So let's say I put in 25 cm cube of sulfuric acid in the flask. Okay, then I carry out the experiment. I find out that 30 cm cube of sodium hydroxide completely reacts with the acid. We again set up the chemical equation. They ask to find what is the unknown concentration. Alright, so we start by asking what is given. When we do calculation, can we find number of moles? Yes, always find number of moles first. What number of moles can we find? Given the volume, given the concentration, I can find number of moles of sodium hydroxide. How to find? Volume times concentration. We now know this is 0.003 mole. If I want to cross over, look at mole ratio. It's 2:1. So number of moles of sulfuric acid equals to half. Okay? Now we know concentration equals number of moles over volume. So the concentration of H2SO4 equal to, divide by what? Do I divide by 25? Remember to convert your units, must convert to dm cube, 0.06. We mentioned before, to convert mole to mass, you times your mR, correct? So the concentration of H2SO4 in gram per dm cube would be H2SO4. You have 5.88 gram. Again, formula first, 5 moles, do your mole ratio, then you find again. Okay, but this time we are not using mass, we are using concentration and volumes. That's why it's called volumetric analysis. Okay, now you try this one. Okay, let's do question 2. Look at what is given. With volume and concentration, I can find number of moles. You go and calculate it yourself. Remember to use dm cube. So the number of moles of hydrochloric acid is 0.0025. So you compare the ratio, 1:1. So your concentration equal number of moles over volume. Volume here, sub in. Number of moles here, sub in. So you have 0.125 mole per dm cube. Okay, finally we go on to the part on gases. 40 cm cube of sulfur dioxide was react with oxygen to form sulfur trioxide. You notice that everything is gas. Therefore, the volume here, we use the equation over 24 dm cube. I suggest you try first, pause the video, then you look at the answer, okay? Start by finding number of moles. Then we do mole ratio. I'm not sure if you notice one thing, because the volume here that I'm comparing, they are both gases, correct? And in my working, right, I divide by 24 and then I times back 24. So I'm like doing one circle, like one big round. Can we do a shortcut method? So the answer is yes. Whenever you're comparing both gases, right, only gases, your mole ratio is the same as the volume ratio. In other words, when I say the ratio of sulfur dioxide to oxygen is 2:1, the volume then would be 2:1, so 40:20. So actually, part A, I don't even need to do any calculation. I can straight away tell you it's 20 because the mole ratio is 2:1. So likewise, if I go by the same logic, right, sulfur dioxide to sulfur trioxide is 2:2. So the volume of sulfur trioxide should be also 40. So with that knowledge, whenever you're doing a mole ratio or stoichiometry question, if you're talking about both gases, so hydrogen and methane, as long as both the things are gases, you can take their mole ratio as volume ratio. So if I have 100 cm cube of this will be 300. Okay, you don't believe me, I'm going to calculate. You get the same answer. Okay, so answer straight away is D. Can? Okay, likewise, I have propane, which is a gas, and then I want the gaseous product, CO2. Okay, so 2.4 dm cube is to 7.2 dm cube because this is a 1:3. So you can understand this concept. It will help you do questions a lot faster. So the next step will be for you to go and do practice questions because the logic is always the same. Equation, moles, mole ratio, then convert. Okay, always follow this set of 4 steps. So I'll see you all in class. That's all for this video.